everyone. Thanks for joining us today. We're back with another video about some very interesting topic in machine learning called privacy preserving machine learning. And we are going to get more specifically into the topic of preserving privacy when we are dealing with textual data and natural language processing tasks. Today I have with me a panel of experts on the topic, and I'm very excited to talk to them. Let's get to know them first.
Hi, I'm Patricia Thane. I'm the co-founder and CEO of Private AI, where we make it really easy for developers to integrate redaction, de-identification, and pseudonymization within their software pipeline. And we work a lot with conversational AI, for example. I'm also a researcher in privacy-preserving natural language and spoken language processing.
Hi, I'm Fatima. I'm a PhD student at UC San Diego, and I mainly work on privacy-preserving natural language processing and ethics and fairness in natural language processing. I've also interned twice at Microsoft Research working on their privacy-preserving systems for large language models.
Hello, everyone. I'm Anima. I'm a Master's of Law student at NYU. I'm currently focusing on antitrust, data and privacy, and international commercial and trade laws during my studies over here.
Hi, everyone. I'm Hugh Nguyen. I am a recovering lawyer and computer scientist, and I am the working co-chair of the working group on data governance at Big Science, and we can talk more about that later.
Hello, everyone. I'm Suhas Pai. I'm the CTO at Bedrock AI, which is a Toronto-based startup where I do NLP research and development. I am also the NLP lead at Aggregate Intellect, where I've been building a community of NLP researchers and practitioners from the past 2 years.
So we have recently heard quite a bit about, various types of data scandals that has happened in the machine learning space and, various industrial applications of AI, where the question of privacy, fairness, and transparency has become very, very important. So since you're coming from the legal background, and Anima, maybe you can tell us a little why that's such an important topic to talk about, and why is now the right time to work on questions related to
You're
this.
right. It is an intersection of law and technology and really ethics as well, right? So as my previous career, I represented companies to advise them on how to not get into trouble with regulators because they're improperly using or the personal information of individuals. However, this is not just a legal issue, but in some countries there are no PII laws, or maybe there are different types of PII laws, like in the U.S., that may not protect the data, for example, in a training set. So we think of it in this Big Science cooperative as an ethical issue. We don't want the information that belongs to people to be released.
Since I come from India, it will be better for me to speak on the Indian antitrust legislation first. So we recently came up with this new data protection bill in which we're, for the first time in 2019, actually addressing the issue of what personal information is. Prior to that, in an economy of 1.3 billion people, this is something that actually never popped up. And this is actually something that very surprised me a lot. What's interesting is that every definition of how privacy is and how personal information is defined is essentially defined in the context of an individual's rights. So in a lot of countries, like Mr. Nguyen said, right to privacy is actually considered a part of the fundamental human rights and one of the basic human rights that a person has. And if we compare this with the definition of under GDPR and as under the Californian Consumer Privacy Act, the CCPA, which has now been broadly implemented on all the big tech companies in the Silicon Valley and everything, you'll see that it's very, very similar. Each of these definitions are actually aiming at identifying a particular, like controlling the information, any information that can lead to the identification of a personal, of an individual. So China has come up with a new data protection law that is essentially very, very restrictive and requires government permission on how data and personal identifiable information has to be used. You have to specify the reason, you have to specify the use, and you also have to take permission to use it from the government besides individual consent. That aspect I'm still looking into, but that is a very interesting thing that will affect a lot of the exchanges that will happen in the
Awesome.
future.
Thank you so much, Anima and Hu, for giving us a preamble of why this is an important problem to think about. So moving on from that to, as Hu said, the overlap of, privacy, ethics, legal considerations, and technology, in this case, machine learning. This has been a problem that has been around for a few years now, and we are still developing a lot of solutions. And Patricia, your company is developing one of these solutions. Can you speak about that a bit? Like, why is privacy-preserving machine learning important from a technical point of view, and what is so hard about it? Why don't we see a good solution?
If you think about all the data that's produced now, about 80% of the data is unstructured data, and that includes text, images, video, speech. A lot of these contain some of the most sensitive information that we produce. Not only because of the content, so you can have social security numbers and credit card numbers, you can have sexual orientation and a bunch of other things that are included in the content, but also because there are inferences that can be made about individuals from beyond from the content. So you can determine who's speaking in a recording, what their educational background is, what their socioeconomic background is, based on their voice, whether they have a particular disease based on their voice, or what the likelihood that it is to in one way or in another. And same thing with writing. You can determine how somebody is feeling in writing. You can use what they write to affect their political opinions. So there's a lot of space to misuse this data. And that's why privacy-preserving machine learning is really important. You don't want parties that have negative intentions getting hands-on personal information and then misusing it for more targeted attacks towards individuals who are of a particular ethnicity, for example, or you might worry about your own data becoming public because it wasn't preserved in a privacy-preserving way, and that actually makes it more likely, for example, to have cybersecurity attacks actually affect data if you don't consider individual privacy. So that's a few of the reasons. There's actually a huge list, but I'll keep it short.
That's quite interesting, Patricia. Thanks for sharing those. So you mentioned unstructured data, and the most typical kind of unstructured data we deal with is natural language, spoken, speech, text, documents, etc. So, Fatima, you are doing research on the topic of preserving privacy when dealing with natural language processing type of tasks. Would you walk us through some of the nuances that exist when we're talking about that type of task and that type of input data?
Yeah, sure. So if you want to talk about it, let's assume like what other types of data there are that are structured. So you can have tabular data, maybe like US Census data, where you have like people's names that you might have removed because of PII scrubbing, but you might have their ages, their income, how many children they have, what their ethnicity is. So you have a number of features. There are a lot of features. There could be hundreds of them, but it's only hundreds. So it's like in the order of hundreds. It's in a table, so there's nice formatting. Everything is like really nice. And you can use like different methods to bring privacy to this. You can like use differential privacy, which would mean you would add some noise somewhere in the pipeline of releasing this data. But when it comes to text, you have sentences. Like the structure you have is a sentence. Sentences could have different lengths. People could say sentences in different ways, like they could change the structure, the grammar of the sentence. And also, even when you look at a sentence, you might have words in the sentence. So there are different words, and these are discrete. So a word is like a discrete kind of element. So unlike a pixel in an image or a number in a table, you really can't add noise to a word that easily, right? Like you want to add noise to a pixel, it can take 256 values. So if you add like 1, 2, 3, it's not going to change the pixel much. But here, how can I perturb a word in a sentence without changing the meaning of the sentence? How can I even, evaluate if the meaning of the sentence has changed, because we don't even have good automatic metrics where you can see if a sentence has the similar meaning as another sentence has. So we have some metrics, but still they're not really that good, as much as human evaluation is good. So there are all these problems. So the problem that language is discrete is one problem. The problem that you don't have structures, you have sentences of different lengths, you have different paragraphs, and also all of these add up to having a lot of dimensions. So you have really, really high dimensional data here, which it's really hard to find correlations between all the different features in the text. And now how can you apply something that is supposed to preserve privacy to this kind of, huge dimensions, discrete data? So that is kind of what makes this problem the hardest, I think, compared to tabular data or even images, where you have, even in images, you have some type of structure, but sentences is just, it's completely different. And one other thing that I really think is important here is that even if you do, you can say that for words, we use these things called embeddings. They're vectors that change, you can have a word and it can change it to a vector. So then you can get kind of a notion of being continuous because you can perturb the embeddings. But even if you do that, even if you perturb those vectors, still, because of the way the vectors are trained, there is some relation between vectors of different words, but when you perturb them, you don't have any guarantees that you're going to get mapped to a similar meaning word, to a synonym. So that's another thing. There's even no real, well-defined structure in the embedding space. There are some works that try to create interpretable embedding spaces where you can have this sense of hierarchy. But in general, in the embeddings we use these days, if you perturb the embedding, there is really no guarantee that you're going to land in a place where the sentence has a similar meaning.
And so, yes, like Fatima says, this is a really hard problem, but we can't solve everything. So in the big science, what we're trying to solve is practically, we want to be able to remove enough PII so that 50% of the time they cannot be identified. So that's really sort of our threshold. It's not a legal threshold. It's more of an ethical threshold, right? Is it more likely than not that you cannot identify this person? So we may perturb or pseudonymize a name or address or whatever it is so that we think by our rule set that it's 51% less or 50% less that they can be identified. And that's a challenge. You're absolutely right.
So one simple thing that can be done, and it's kind of the thing that a lot of people are working on, I don't know if a lot, but I've seen some papers, it's how to remove the structures that we can maybe find. Something that we can do and we can find and remove is PIIs. So these are personally identifiable information. It could be names, it could be people's age, it could be anything that can be related, linked back to them. So this is really important, especially in medical data. I know there's this HIPAA regulation that says there are 18 or 16 types of PII that you need to be able to remove before you can release medical notes for someone. So how we can find those things and how we can remove them itself is a problem. Even though this might seem simple, right? It's names, just find the names and remove them. But even with removing names, which you can use named entity recognition systems to try to find and remove them, it's not that simple because names can, especially in English, names can also be nouns. House could be someone's last name. It could also mean house. How am I going to figure out if it's a name or not? Or there are a lot of different things. Or when you have other languages, a last name might mean something there, but it could be a last name here. So there are a lot of nuances there with recognizing named entities and PIIs, which could not just always be names. And again, there is no structure to just remove a template.
There is, in addition to that, an added difficulty depending on the kind of data that you're dealing with. So if you're dealing with transcripts, for example, not only are you dealing with the disfluencies that humans naturally have when they're speaking, but you're also dealing with the idiosyncrasies of the transcription system. So it adds an extra layer of complexity, especially considering that these models are pre-trained on sometimes on pretty standard data, sometimes on pretty messy data, but it's not necessarily data like the one that you're looking at. And so in addition to it just being hard to do named entity recognition, there's also the complexity that even a human in some cases might not necessarily recognize what is personally identifiable information in these scenarios. A lot of the times the data that you would want to collect for projects like this tend to not be usable for commercial use. So that's an added layer of difficulty when it comes to training a model that can be deployed in enterprise systems.
Around a year ago, Carlini et al. Showed convincingly that language models memorize training data and that the model can be prompted to spit out specific training data given the right prompt. So a contrived example would be if there was a sentence in the training data, Suhas's social security number is some number. Then if you provide a prompt to the model, Suhas's social security number is, and then allow the model to provide the continuation. And if the model has memorized this specific instance, it's going to reveal your social security number. There are several different ways to construct these attacks. The membership inference attacks have been demonstrated even on static word embeddings. Moreover, it has been shown that the larger the language model, the more easier it is for a model to memorize training data. Therefore, it becomes very imperative to eliminate any kind of PII present in the training data for these large language models. On the other hand, there is a contradictory objective. You would expect a large language model to act as a knowledge base and be able to answer questions about the world, like who is the 10th Prime Minister of Canada. Thus, you need to make an exception for public figures, and satisfying these two goals can be very tricky.
All right, very interesting. So what I understand from what you said is that it's definitely a very challenging task, and there are a lot of nuances that we have to deal with. But the minimum that we can do, at least right now, is to recognize personally identifiable information, probably using techniques that we use in NLP, like named entity recognition, and then figure out how we want to handle it. So is it the type of information that we're allowed to use, that it is clear to be used, or is it the kind of information that needs to be anonymized or masked otherwise? So Suhas, maybe you can walk us through what PII, personally identifiable information, means, and how we use techniques like named entity recognition to deal with it, and what are the differences and nuances there?
NAR, or named entity recognition, is an NLP task that deals with information extraction from text. In this case, identifying entities that are part of some predefined categories, like names of people, places, organizations, medical codes, etc. PII, or personally identifiable information, is information that can be used to directly or indirectly identify an individual.
On the topic of dealing with information and data that is going to large language models, there's this big significant project going on right now called Big Science, which is trying to address many different aspects of that question, like how is the data going to be governed, or what kind of data is possible to be used, and in general, what are a lot of the ethical and transparency and governance related questions we have to think about. And you're the co-chair of one of the working groups. Can you give us a high-level understanding of what is Big Science, what are the objectives, and very concisely who's involved?
Yes, Big Science, as you said, is very big, right? It is a cooperative of over 700 researchers from many universities and institutions, all focusing on open research, doing natural language processing for a very, very large language model. And so if you don't know what a large language model is, I can explain it briefly. It is the techniques for being able to train what we call transformer models right now to do a lot of different downstream tasks, which are very, very good. So it could do almost human-like understanding, recognition, translation, and so forth. But the problem is that in the past, large institutions like OpenAI, Microsoft, Google, and you name it, have created these language models, and in a closed sort of way. So we don't actually know how they did it, and some of it's not even released. And even governments do that. So Big Science was granted a lot of GPU time from the French government. I mean, like millions of dollars worth of it. And we're going to train a very, very large language model. And we're doing it all out in the open. People who are researchers can join. And we want to do it in an ethical way. So what does that mean? That's part of what we're trying to figure out. We want to do it in a legal way. We're talking about data going from many, many countries, and we want to be able to do that that respects the laws of different countries. So the project here, and I'm the co-chair of the data governance working group, is to figure out how to get the data in and do it in the right way. Right? And so we want to make sure it's actually cleansed in some ways before it's trained and then released out into the world. Because the Big Science Project is training a large language model, which I think a lot of the members of this group knows. Right? It's doing natural language processing. It takes data. And the data will probably be web scrape data, social media data in some respects, and also some other data like book data and so forth. So there may be information about people's health information, their names. I've actually seen data that with people's social security numbers, surprisingly enough. So the data is there. We want to make sure that we ethically don't put that data into the model and then somehow, Bob somewhere tries to get the information out and uses it and abuses it. So that's the main point of our project. And there's a lot of laws, but that's the point.
Thank you so much, Hu, for walking us through that. Suhas, you are leading one of our most vibrant sub-communities around NLP, and we are getting engaged with this big initiative. Can you talk about how you're engaging in this, and what are the objectives of the specific projects that we are going to do to contribute to Big Science and this huge effort that is going on?
The NLP group at Aggregate Intellect is very excited to be participating in this community project, along with Big Science and our other collaborators, Ontocord.ai, Lighttag, and Masakhane. We are a very diverse group made up of people from all over the world, and we are putting this into work by sourcing datasets for detecting PII in Hindi, Mandarin, Persian, and Arabic, and then building NER systems in those languages, and eventually coming up with suitable techniques for replacing PII detected in language model training data with surrogates. Our collaborators include Ontocord.ai, founded by Hu Nguyen, who has been very instrumental in setting up this project, Lighttag, which is a tagging tool, and Masakhane, which is a Pan-African NLP community, which has made leaps and bounds in bringing NLP advances to the low-resource languages, and whose NER tool, Masakhane, is a major source of inspiration for our project.
So in Big Science, we have narrowed it down to like 7 language groups, but we're open to other types of languages. So if you guys want to do, for example, Persian, that's something I think that there's a large community need for. We will welcome that.
Oh, very quickly, let's recap what kind of information are sensitive and potentially can be used to identify individuals, and what are some of the nuances around recognizing that type of information and handling it.
Like Fatima and Patricia said, you can use any type of information to identify a person, the word choice and so forth. But we can't really deal with that issue here. What we're dealing with is traditionally what we thought of under the GDPR and under the California laws as traditionally PII, name, plus some other information that identifies a person. So name itself actually does not identify a person. Like John Smith does not identify a person, right? Even Hugh Nguyen, you look me up on the internet, there's a lot of me. Which one is it, right? But you add other information that's more likely than not to identify a person, including information outside of the system, outside of the data set, then that would be considered PII. So that's why it's a hard problem. It's not just NER, name entity recognition, like, I'm going to recognize a name, an address, an org, and a GPE. No, it's actually we have to decide which part of the NER together combines to make PII. So I'll list some of the things, like in the EU laws, social economic class, strangely, something very important, right? Union membership, political party affiliation, right? name, obviously. So you add all those up, more likely than not, if it identifies a person, health information. So it's broad, but it's not. We're not identifying, for example, like whether something is a work of authorship, right? We're not identifying a case name. So we're not going there. But we do need to identify a broader number of what we think of as name entity recognition than normal. And it's not NER in the sense of like a proper name. It's actually like, it could be a pronoun, right? A pronoun plus a full name plus a location could identify a person.
Yeah, great point too. We grapple with this every week at Private AI with different cases that pop up here and there. So one of them is, for example, I called the police, not something that's identifiable. I called the Manchester police, more narrowed down. I work at the Manchester Police Department, much more narrowed down. So it's these little nuances that are so, that there's so many of them all throughout the text, and it requires quite a bit of thinking through that do make quite a bit of a difference between an NER system and a PII detection system.
Thanks, Hu and Patricia, for telling us about this. So far, we've focused a lot on why this is a hard problem. So let's talk about where we are, even from like a research point of view, state-of-the-art research, and even the industrial implementations of those ideas. So Patricia, maybe you can tell us a bit about where we are.
Yeah, sounds good. So it depends what kind of data we're working with. It depends what system you're using. So there are a number of systems out there that are for example, open source. For example, there's Microsoft Presidio. There's also Spacey that some people use. Then there are more commercially available systems like Google DLP, AWS Comprehend. From all our tests that we've conducted, specifically on held out test data on really messy forums discussing cancer and very complicated names for say medications and procedures, Private AI system is actually outperforming all of these. And the reason is because we focus a huge amount on the data itself, as well as tuning the models specifically for this task. And some of the data processing includes going over the data sets that we've labeled 3, 4, 5 times, and any time that we find a new entity that needs to be added, we have to go through that data again in multiple languages. So in part, it's it's about access to the right kind of data. In part, it's about about creating models that work on large amounts of data as well, because you might have, for example, 1 or 2 documents that you want to redact, in which case you might do it manually, but then what you're looking for is systems that can work on millions of documents per day. And for that, you need to make models that are really efficient, which is something that we've worked a lot on and have gotten there. And in addition to that, I would say that anytime you have a new use case, it is important to get a little bit of the data for that use case in order to get an idea of whether that model generalizes to it or not. And we can get to 99+% accuracy for specific use cases, which is really exciting at this stage.
All right, that's quite interesting. I remember, Fatima, at the beginning when we started, you mentioned the typical techniques that we use to handle private information in machine learning. You mentioned, differential privacy, and there are other techniques like federated learning and such. So beyond just, entity recognition type of approaches, what are some of the things that we can do once, we achieve the lower hanging fruit of identifying entities and handling them? What can we do beyond that? And, hopefully that will be the future phases of the project that we are doing.
Removing PII is like a step 1. Once you've removed it, you want to do something with the data. You want to learn a model. You want to gather some statistics, something. So at that point, that is where you can take other measures to preserve privacy, like differential privacy. Because even like if you remove PII, there is still something in the sentence that could reveal or could link back to a person. It might not be an exact thing. It might just be, as Patricia mentioned, their style of talking or how they're writing. It might reveal their mood. So there are things that you can't like easily remove from the text while keeping the meaning. So in these points, and if you want to train a model on this data, instead of just trying to, wash the data and like clean it up, what we can do is use the data as it is and use differential privacy to get some kind of guarantees on how much information is going to leak into our model. But now the open problem here is that with text, as I mentioned, you have a lot of dimensions. So just using differential privacy as it is, which is like just adding noise during training, can cause a lot of degradation in the utility of the models that we get. So unless we have a huge corpus of data, like huge data, and we're using that to train our model, we're going to see a lot of degradations in utility. So one question is, how can we maybe better adjust our differentially private mechanisms for text so that they can handle this huge dimension, and also some potential correlations between data. Because, there are some sentences or some phrases or even names, if they're not removed, that might be repeated in a document. And what happens with differential privacy is that, like, the more you have repetitions of something, the more privacy budget you're losing, and the easier it is to extract that sentence or that phrase that is repeated. So what are some ways that we could handle this? How can we, like, identify these types of sequences in text? So that is like one whole direction of research could be just how can we get better differentially private mechanisms for text. Another direction is kind of like by design, what can we do to preserve privacy? So that could be federated learning, although I really want to make this clear that federated learning does not have any guarantees in terms of privacy. It's only nice because your data never leaves your device, so you're not sharing your raw data. You're training models on your local device and you're sharing the models. So you're still leaking information, and if you do federated learning alone, you don't have any privacy guarantees. Although it is privacy enhancing in terms of just not sharing your raw data, but that is like one good step because it's like when you're even training your model, you're thinking about privacy. So that's kind of privacy by design. The model is designed in a way that you're not sharing your data. As opposed to, trying to train a model and then after the fact thinking about, okay, how can I dememorize data or delete personal data from this? So I think it's really important that we think about privacy as something important during designing our systems instead of just making our systems and then at the end be like, okay, how much does this leak? Let's measure the leakage. Let's try to decrease the leakage. That is better than nothing. But what's best is if we think of privacy when we're designing the system. All
right. So there are lots of low-hanging fruits that we can go for in this project and all the other similar efforts that are going on. And as Hu and Fatima mentioned, there are a lot of potential and challenges that we'll going to have as we go forward with more advanced techniques that we can use eventually. At this point, I would love to wrap up the session by asking each of you to, very quickly tell me what is the one question that you're personally excited about to see solved, either in academic circles or industrial applications, when it comes to privacy-preserving machine learning and more specifically NLP.
The part that I'm most excited about is really getting to the crux of the problem of how to make privacy really accessible to developers. Because there's a huge amount of complexity when it comes to creating privacy-preserving tools, and there's not enough time in the day for people who are working on a core problem to also think about how to preserve the privacy without having the right background of the users that they're working for. So that making complexity easily accessible in only a few lines of code is something that I'm constantly focusing on and really passionate about.
So one question that I always have in my mind is just around the memorization of language models and basically all deep models. I think if we can figure out how memorization is happening and what is being memorized and how we can control it, or what learning versus memorization, then not only it will be easier for us to do privacy-preserving NLP. It will also help in terms of fairness and ethics and transparency, because a lot of the biases that we see in models is biases picked up from the data. So if we can just uncover the memorization, what is the model picking up, and kind of have control over it, I think we can help a lot of aspects of trustworthy NLP.
What I'm personally excited about is democratization of access to NLP technology. to people, from my own country, from Vietnam, and now the U.S., to under-resourced communities in Africa, for example. So we want to build tools that everyone can use, right? And I understand that big science is going to build very large models, but part of it, the discussion, the analysis, is how to build the data pipeline so that all researchers can use it. And I think we will create the largest PII-preserving data set of all time through this project, and it's going to be super cool.
All right, thank you so much, all panelists. It was a pleasure talking to you today about this topic. I personally learned a lot. I know that it is very important to make it as easy as possible for developers not to have to think about, developing privacy-preserving softwares, because, that's an important topic. It shouldn't really be on them. You should make it easy for them to do that. Like Patricia mentioned, I'm very excited to see, what kind of, progress we can make in understanding our large language models better. What is the mechanism and mechanics of learning versus memorization, as Fatima mentioned. And I'm also very excited to see how we can develop tools that really serve underserved communities who are interested to, work on machine learning and NLP tasks, and solve the big problem that is happening in the past few years, where the language models are becoming bigger and bigger and less accessible. So, moving on to that mode where we can make, working with natural language processing tools transparent, fair, ethical, and really inclusive is where we are going with this project. And I'm really hoping that you are excited as much as I am about this project and join us. Again, the link about more information and joining is in the show description. So take a look, send us an email if you have any more questions, and we are happy to help you and onboard you to this project. Thank you for watching, and hope to see you.